This is a video working through two problems off of the Chapter 10 review homework, exercises 9 and 10, which are really similar questions, but we'll solve through both of them. So they're telling you have points of tangency and that you're needing to find a value for A. So what you're doing here is I guess you're having to recognize that the two things are equal. So if you've got a point off of the circle and you're drawing 2 points or 2 lines to hit at tangent points, those two are equal. So that's the geometry setup. So geometry is saying, okay, here's a true statement. 9a squared minus 30 equals 3a. And then you're wanting to solve for a. And then this is where the algebra kicks in. In order to solve this, you have a quadratic, which to solve it, what you want to do is gather everything to one side of the equation. So I'm going to subtract 3a from both sides. So I've got 9a squared minus 3a minus 30 equals 0. So again, what I did there was just, and I can even write it here, I'll use a different color pen. What I'm going to do is subtract a 3a from both sides. And when you do that on the right-hand side, it's pretty clear 3a minus 3a is going to get you 0. Then on the left, what you're going to do is I just put it in order. So I did 9a squared, I inserted the minus 3a in the middle, and then I've got minus 30. And then what you're looking to do is factor it. So what you want to do at this stage is figure out, do these three pieces all have a number in common? In this case, they do, and it's a 3. So I'm going to take that 3 out, and I'm left with 3a squared minus a minus 10. And then you have to factor this expression, which is a tricky thing to do from an algebra standpoint. You're going to draw your factoring in, and you're going to say, okay, so to get 3a squared means I need to take 3a and a. That's the only way to get 3a squared. There aren't any other two values that do that. And then you have to generate a 10. To get a 10, you can either use a 1 and a 10, or you can use a 2 and a 5. And it's not immediately apparent which one you're supposed to use. It also has to be a minus, so one's got to be plus, one's got to be minus. And in this case, we need to generate a -1 or a -1a in the middle. To do that, just by virtue of having done these as long as I have, I can see what it's supposed to be, but it takes practice. And in all honesty, it takes a lot of mistakes to get to the point you see it. But this is going to be a +5, and this is going to be a -2. And the reason that is, so I chose the 2 and the 5. The reason that is when I do 3a and arc it to the 2, I'm going to get a -6a. And when I do 5 and arc it to the a, I'm going to get a +5a. And then those two are going to combine to get me my -1a. You already know you're going to get 3a squared, and you already know you're going to get a -10. So I can certainly do those arcs, but I don't need to check those to determine I've done the right setup. And then what you're saying is, okay, I've got these two pieces, and to make this thing true, only one of them has to equal 0, because if one of them equals 0, the whole thing equals 0. So the second one's actually easier to do. You add a 2 to both sides, and we get a equals 2. Which is going to be the answer, and we'll get to y in a second. And then on this one, we're going to subtract a 5 from both sides. So we get 3a is -5, and then we divide by 3 and get -5/3. Now, it's not a problem that it's a fraction, but in this case, it's actually a problem that it's a negative. Because if you think about using that, if you've got a side that's 3 times a side length has to be a positive number. And if we're going to say a is this negative amount, it's actually giving us an incorrect solution. Which happens with quadratics. When you're applying them to a real situation, you have to apply kind of a common sense check to say, does this actually generate a number we can use? So if I took that 2 and plug it in, sure enough, 3 times 2 is 6. And actually a good check to see if we're right is to take that 2 and plug it in here. If I do 9 times 2 squared is 4, so 9 times 4 minus 30. Well, 9 times 4 is 36, and 36 minus 30, sure enough, is 6. So we check. We're good. So that's how you do it. Set the two pieces equal, and in all honesty, that's the only geometry step. So I'll say geometry. The rest is algebra. I guess, technically speaking, making the decision to only use the positive would be a geometry step, technically. So that is number 9. Number 10 is really similar, so let's take a look at it. So you've got the same setup. You've got two things that you're going to set equal. Because we have this exterior point with tangency. And then what you're going to do is get everything to one side. I tend to just get everything to the side that has the squared term on it, so I'll subtract away a 9c. And I'm going to do them one at a time, just so we don't get overwhelmed by it. And actually what happens here is a little bit different because those zero out. I'm left with plus 6 equals 14. Okay, so what makes this different is once you lose that central term, once you lose that term that's in the middle, you no longer have to solve by factoring. And I know that can be a little challenging or confusing to know, like, okay, when do I do one, when do I do the other? The reason we had to factor, I'm just going to scroll back up here. The reason we had to factor is when we moved the 3a over, we created 1, 2, 3 terms, or 3 pieces. There's no other way to solve that than via factoring. But here, that first step, when I did the subtract 9c, it knocked it away from both sides. So now actually I don't need to get everything to the same side. I can just go ahead and solve this in a more straightforward way. So I've got 2c squared, and then 14 minus 6 is 8. And I'm going to divide both sides by 2, which gives me, I'll scroll up a little more, c squared is 4. And then when you take a square root of both sides, so when you introduce a square root into the problem, we're going to do square root of 4, which is 2, but it technically has to be a plus or minus 2. And the reason being is if I plug that back in at this step, if I take a positive 2 and square it, I get 4. And if I take a negative 2 and square it, I get 4. So in mathematics, the way we show that is with this little plus minus sign. And it's not like a new number. What that means is literally positive 2 or negative 2 is your answer. It can be one or the other. So again, here, we have to put in a lens of reasonability. If I were to take that negative 2 and plug it in, I would get 9 times negative 2, which is a negative 18 plus 4. Or negative 18 plus 14, which would give me a negative 4. So that doesn't work. So the negative 2 doesn't work. And then the answer I'm left with is a positive 2. So C is going to be positive 2. And we can do that same check of saying, okay, let's plug that 2 in. So I'm going to get 18 plus 14, and that's equal to 32. And then if I put that 2 in up here, I better get the same thing. So let's see, that would be 2 times 2 squared is 4, plus 9 times 2 plus 6. So that would be 8 plus 18 plus 6. 8 plus 18 is 26. 26 plus 6 is, sure enough, 32, and it checks out. So checks, it works. So I guess actually, while the problem setup's the same, you end up solving them 2 different ways because in the second one, you don't need factoring. On the first one, you do.